Welcome to lecture 7 on shear force and bending moment. In this video lecture, we will discuss about a cantilever beam with a point load. Let me consider this example. A cantilever beam carrying a 10 kilonewton force point load at its tip. It is supported at A. The span is 3 meters. Not necessary to calculate reaction and moment, but as a practice we will do it. Using the equilibrium equation, summation of all the vertical forces equal to 0, so that the system will be in equilibrium. So if you consider this, there are only two forces in the system. One is reaction, another one is the point load. So reaction must be equal to the magnitude of the point load. So on the other hand, we have a moment equation. Summation of all the moments equal to 0, so that will give a value of 30 kilonewton meter as a moment value. Let us study the shear force at A and B. Same steps we will follow. We will consider a section XX at a distance x from the free end. If I write shear force for this, so by definition shear force is summation of all the vertical forces towards the right of the section. Towards the right of the section there is only one force, 10 kilonewton force, acting downwards. So when a force is acting downwards towards the right of the section, it is considered positive. So shear force is a positive value and it is a constant value throughout the section A to B, throughout the length of the beam. So it is not dependent on x. There is no x term in the sigma fx function. It's a constant value. So irrespective of x value is 0 or 3 meters, the value remains constant. Let us draw the shear force diagram now. Let me draw the A and B points, reference points. Let me represent the beam AB, 10 kilonewton positive. So in the sense I need to draw that above the AB beam. So it's a positive value. I can represent like this. Let us draw bending moment diagram. Let me calculate the bending moment at A and B and draw the bending moment diagram. Again, we should consider the section XX at a distance x from its free end. So bending moment by definition, it is summation of all the moments towards the right of the section. So here towards the right of the section there is only one force, that is 10 kilonewton. So about the moment about xx is mx, that is equal to 10 into x is the magnitude, but where the sign convention towards the right of the section, if a moment is clockwise, then it is negative. Moment is clockwise towards the left of section is positive. Moment is clockwise towards the right of the section is negative. So minus 10x. At x equal to 0, the moment is 0. At x equal to 3 meters, the moment is minus 30 kilonewton meter. So let me draw this in a BMD diagram, bending moment diagram. Let us represent AB beam, minus value, negative value, minus 30 at position A. It's a linear, connect a line between 30 kilonewton and B, 0 kilonewton meter. So it is the negative bending moment. So if you observe here, when there is a point load acting on the cantilever beam at its tip, shear force is a constant value throughout, whereas the bending moment is linearly varying. If you remember our earlier discussion on UDL acting on the cantilever beam, when UDL was acting on the cantilever beam, shear force was linearly varying and bending moment was parabolic variation. But whereas here, when it is a point load, shear force is a constant value and bending moment is a linearly varying value. Okay. Thank you for watching. Thank you.